All right. So, getting into the next lesson here, multiplying fractions. Before we do that, though, we'll do this kickoff here. So the chef of a pizza place uses 12 and 9/10 packages of pepperoni, 6 and 3/10 packages of sausage. How much more pepperoni than sausage did the chef use? Well, the how much more, again, those are key words saying, hey, we're going to subtract them to find out the difference between the two to know how much more the pizza was. Pizza place uses pepperoni than it did sausage. So 12, 9/10 minus 6 and 3/10. Now, start with your fractions. Check for common denominators. We have them. They're both over 10, so we can subtract our tops. 9 minus 3 leaves us with 6 over the 10. 12 minus 6 is 6. And then we can reduce the 6 over 10 down to 3/5. Okay. Now, similar kind of stuff we'll be doing here, but now we're railroad tracks, or multiplying fractions. So I want you to think those railroad tracks. So if you think about railroad tracks, when that train runs down those tracks, the wheels stay on that rail. They don't hop back and forth between the rails, so they stay straight on the rails. So think of that top is the one rail, so you're going to multiply those two. The bottom is the other rail. You're going to multiply those two. You're not going to hop back and forth from rail to rail. Tops times the tops, bottoms times the bottoms. So if we're going to multiply 1/4 times 3/4, again, railroad tracks. Tops times each other, 1 times 3 is 3. Bottoms times each other, 4 times 4 is 16. And that's it. Now, always check to see if you can simplify. This one we can't, so that's as far as we can take it. 3/7 and 6/7. Again, railroad tracks. 3 times 6, 18. 7 times 7, 49. Again, check to see if you can simplify. Here we can't, so we're going to move on. Now, sometimes when we get into bigger stuff, we can reduce a numerator and a denominator with a common factor before we even multiply. Now, if you don't really like doing it that way, you can still do it after, just like we've been doing it for how long. So I'll show you a couple of ways here. So first, 9 on the bottom, 3 on top. Those are factors of each other. We could divide both by 3. This would become a 1. This would become a 3. And then we can multiply them. So 1 times 1 is 1 on top. 3 and 4 make 12. Now, if I would have done 1/9 times 3/4, 1 times 3 is 3. 9 times 4 is 36. I can divide them both by 3 and get 1 over 12. So, either way, you're going to get the same thing. For me, I like doing it this way because that makes the smaller numbers easier to multiply them out. Now, I know 9 and 4, 1 and 3, not that hard to do. But if we get into bigger numbers, that could get really hard. So if you can make them as small as possible, it'll make it as easy as possible to multiply. Now, if we're multiplying 3 or more terms, so if we're doing more than 2 here, we still think railroad tracks. So we still are doing the tops, still are doing the bottoms. Now, one thing we can do, it's any one of these we could reduce. So this 5 and this 5 are reduced to 1 and 1. Now, 8 and 3 doesn't work. 8 and 1 doesn't work. 2 and 1, 2 and 3, 2 and 1. No more that we can reduce. So we're going to multiply straight across. 1 times 3 times 1 is 3 on top. 8 times 1 times 2 is 16 on the bottom. And that's as far as you can take it. Now, say we would have been doing it if it's 5/8, 3/5, and if this would have been 2/3. Just for example, here we would have crossed the 5s and got them to be 1s. Here we've done 3s to make them 1s. And even though they're not even close, this is a numerator, this is a denominator, this would have gone to 4, this would have gone to 1. So it doesn't matter, they don't have to be just right next to each other is where I'm going with this. Here there's here it's over here. We have a whole number in between. It's still 1 on top with 1 on the bottom. If there's a common factor, we can reduce them. So let me know if you have any questions. You can always pan me, send me a message on Google Classroom, or email me. Otherwise, until next time, we'll talk to you later, guys.